and welcome back. Section 9.5, we're going to look at a certain thing that we can do with vectors, and we can find what's called the dot product. So the dot product is going to involve two different vectors, and the dot product of u and v is given by u, and then it's got the multiplication dot, so it's read as u dot v. I know it's clever. And to find it, you're going to take the first two numbers, kind of like the x-coordinates, and you're going to multiply them together. And then you're going to do the same thing for the second numbers. So the b's, multiply them together, and you're going to add them up. So what this does is this actually does not give us a vector. This is a scalar. So the dot product just takes two vectors and kind of takes the product, but it gives us a scalar back and not a vector. Okay, so associated with the dot product are parallel vectors. So they're parallel if one of the vectors is a multiple of the other one. So if you're looking at your two vectors and you're like, hey, this one's just twice the size of that one, that means they're parallel. So orthogonal vectors are vectors that are, you guessed it, perpendicular. This is a real mathy way to say it, and it sounds kind of cool too, orthogonal. So the two vectors are orthogonal if you take their dot product, and it actually comes out as 0. So the dot product has some properties as well, and they're kind of straightforward. Order does not matter for dot product. It kind of like distribute across a vector sum. If you take a vector and dot it with the 0 vector, you just get the 0 scalar. And then a dot product of a vector with itself is the square of its length. Now the dot product is also useful in finding out the angle between two vectors. So cosine of theta is going to equal u dot v all over the magnitude of u times the magnitude of v. So the dot product, we could rearrange this, and this was actually a typo. I think I took it out of the notes, I can't remember. But just delete cosine of theta equals right there, just cross it out. So we're going to take this formula and we're going to get the dot product by itself. So that would be u dot v is going to equal, we're going to take the denominator and we're going to swing it over in front of the cosine. So the magnitude of u times the magnitude of v times cosine of theta. Okay, so let's actually start working with stuff. So example 1, find the dot product and then the angle between them and state if they're parallel, orthogonal, or neither. So we should be able to do this no problem. So let's get the dot product first, since that's what it told us to do. So take the first two numbers, so the 3 and the 6, we're going to multiply them, and then plus, now take the second two numbers, so the numbers in front of the j's, and multiply them together. And then just do the math. So 18 plus 8, most of the time comes out as 26, so that would be the dot product. So we know they're not orthogonal because we didn't get a 0. Okay, so let's get the angle between v and w. So cosine of theta is equal to the dot product divided by the length of each of the vectors. So the dot product we just found was 26. Now we need the length of vector v, so square both of these numbers and then add them together. So that'd be 9 and 4. be 13. And then same thing for vector W. So that'd be 36 and 16. Should be 52. So if you actually reduce this down, it comes down to 26 over 26, which is equal to 1. So cosine of theta is equal to 1. Well, cosine of theta, you know, where does it equal 1? Well, that would be theta is equal to 0. So that's the angle in between them. So they're actually kind of, bam, sitting right on top of each other. So let's see if it's parallel, orthogonal, or neither. We know it's not orthogonal, so they're either parallel or neither. Now, because we got 0, chances are it's going to be this one, unless they're pointing in opposite directions. But that would have probably come out as theta is equal to 180. So look at your two vectors and the numbers that are involved. Can you multiply vector v by something and give you vector w? Yes. If you multiplied vector v by 2, that gives you vector w. So w is a multiple of v. So that means they're parallel. All right, let's try the same thing with a vector, example b. So get the dot product. So the numbers in front of the i's, multiply them. Number in front of the j's, multiply them together. So we have 18 minus 18, which gives us 0. So there's your dot product. Oh, ooh, that tells us something. You got 0 as a dot product. So since the dot product is 0, that implies that the two vectors are orthogonal. Well, if the two vectors are orthogonal, that means that they're perpendicular. Well, if they're perpendicular, that means that the angle between them is 90 degrees. There you go. All right, let's do this last example, and then that'll be it for 9.5, kind of short. So find A so that the vectors v and w are orthogonal. So that means you need to find the dot product. And if they're orthogonal, that means it has to equal 0. So we need to find out what this is, have it equal to 0, and then solve for A. So the dot product, you'd have 1 times 2 plus negative A times 3 equal to 0. So 2 minus 3A equals 0. So A would have to equal 2/3. Okay, so we did skip a good portion of the notes, but you guys can just sort of read that on your own. That I'm not going to require you to memorize it. That's just the background information on kind of how the dot product came into being, but all you need to know is really just how to use it, and like for example 1 and example 2. So go ahead and try the homework out and let me know if you have any questions.